Hi there, this is Pranav from DBS Diary. I hope you are doing well. Good morning, afternoon, evening, depending on the geographic location. So today we are going to talk about execution plan. Okay, how do we make sense of it, and what all things are there which is part of execution plan? Few operators, and then we'll also see the stats, logical stats like logical read, physical read, then CPU time and execution time, and total you can say logical total reads, okay, and writes, right? And then we'll also see something regarding which is relative execution versus the actual reads, right? So this is all things that we are going to cover today. So thank you for tuning in, and if you like my content, please do like the videos and subscribe to my channel. Okay, and in case of any question or concern, I mean this topic or this subject was raised by somebody in my in the comment on one of my videos, so I thought I will cover that. Okay, so I have prepared set of commands, and that I will execute in the lab, so that you will get the idea like how do we really do that and how to read the plan, right? Because there are many people who are not really aware how to read the plan, and even if they know how to read, but then how to make sense of it, right? And using the execution plan, you can really you can do the baselining of performance, and then based on some changes like creating index or then dropping some index, or maybe changing the query, all that thing, how will you compare it? So that's where execution plan comes very handy, and then you can use that to really showcase your work. And then you can see it was 100,000 before, now it's only 1,000 or 2,000. So how much improvement you have made by introducing an index on certain column, or changing the query to some extent, or there are many things that you can do, right? I mean, changing the locking scheme for handling deadlock or for handling blocking. So all those things are there, but then unless you see the execution plan, you can't really make sense of that, and how, I mean, you can't really derive what should you do, right? Okay, so I have my lab ready. Let me start recording first, okay, so that you can see the lab. So these all are the command that I have prepared. So before that, let me get into my lab. So this is my lab, okay. Now before start, let me show you, I have one server here, ASE1, okay, and then I have opened two sessions. So you can run the same command here, and you will see that there are one Sybase ASE instance running in this particular server, okay. So now what we'll do is we'll log into this. So in one we'll do the changes, and in the other one we'll see how it actually impacts, right? So before really moving forward, what we need to do is we need to create a table, right, and fill the data in that, then only we can move forward, right? So what we'll do is we'll find an easy way to create table and to populate data into that, right? So let's go ahead. So as all of you are aware, we have a system table, right? This is messages. So we'll insert data from there into a table which we'll be using for our lab purpose. So select star into test underscore messages from master dot sys messages, right? So what it will do is it will start inserting data into your database into a table which is called test underscore messages, right? ISQ minus S ASU1 minus USA. Now you can give Windows size and insert the password. Now use user DB. So this is the database which I am already having. If you want to see the detail of that, you can do sp underscore help DB and user DB. So you can see what is the size of that, and then segments which I have covered in my training session. If you have not participated, or if you have not really shown interest, or you have not really paid for it, you can pay for my course where I have covered around 20 to 21 topics. In that I have covered also segments. I have also covered database, how to create database, how to create device, how to alter database, then logins, user, alias, a lot of things are there. You can go through that, and if you have not really bought it yet, you can buy it. It's at very nominal price. I am also going to put all this topic wise content, and you can just buy one of them, or you can buy a transcript, or you can buy the video, or you can buy the complete thing, which will be with the both, like video as well as transcript or it will be in the form of PDF. Okay, so that is how it is. So let's create the table now. Okay, before doing this, you need to have select into enabled. If it is not enabled, it's a DB option. Again, this also I have covered in my topic, in my list of topic. Okay, DB options and their significance. Okay, so this option has to be enabled, then only you can do select star into. Okay, so let's do that. So you will see that 10,096 rows are there in your table now, test underscore messages. Okay, so we can play around with this. Now if you want to see the data in this, data means the metadata, then you can do like this, and you will see that the size of table is around 290 pages. So it's a good number, and row count is 10,986, right? This is what we have seen just now. Okay, so now we'll log in here as well. Sorry. Okay, we'll use the same database so that we could use it. Okay, and now we will start with the things. This one we have seen. Now let us start the execution plan and how do we really use that. Okay, so set show plan on. This is the command to see the plan. Okay, so now if you do select top 10 star from test underscore messages, right? This is what is the table that we have created now. So now you will see that the 10 rows are displaying. Now let us see the plan of this. So see, query plan for statement 1, optimized using serial mode. Okay, 2 operators under root. Why 2 operators? So basically we are doing from and also putting the limit of the number of rows. So we want only 10 rows. We don't want to see the all the rows in that. So it will go for table scan. Okay, it will do forward scan. Okay, and then it will start displaying. So forward scan means it will start from starting point, and then it will go start like traversing, and it will limit itself to only 10 rows, and then it will start displaying. So it will not go for complete table read, right? It will just start there. So now if you want to see the like how much logical read were involved or how much time it has taken. So for that there is a command called set statistics. Okay, IO comma time. So IO will show you the logical read and physical read, and time it will show you the CPU time and the execution time. Okay, so this one is done. So now what we will do is we will run the same command that we executed before. So select star from, select top 10 star from, okay, test underscore messages. Okay, now let us see how it actually looks like. Okay, so you see that the plan will not change. Okay, it's table scan, forward scan. Okay, and then you will see the 10 rows are displayed here. Okay, and then logical read, one logical read. So it has actually read only one page. Okay, which is starting, it started from starting point and it went till 10 rows. Okay, and then it is displaying. So only that much it has read. So in that the cost is only one page. So it has gone through only one page. How much time it took? It's 0 millisecond. So basically it has finished in microsecond or less than 1 millisecond. So it's 0 point something 00 something like that. Okay. So now what we'll do is, now we will start putting the order. Okay. So here what we did is we only did select the top 10 star from test underscore messages. So whatever is the order, you not really care. And if you see, it's actually printing the data, the record based on the error number. Okay, it's 1, 21, 101, 102, 103. Likewise, it has displayed in the ascending order of error number. Okay. So now what we'll do is we'll give some extra work for the optimizer. So we'll say order by error, even though it is already doing the order, but we will mention that separately, order by error. Okay. So now if you see, since we have set order by one specific column, so now it has to get the complete content of table, then it has to arrange the data arrange the rows in the order of error number, then it will put the limit. So now it has to do lot more operation than what it was doing before. Okay, so you see that now there is work table 1 is involved. Why? Because now it has to store the table data, then perform the ascending and descending order. So in this case it is ascending order. So you will see it is forward scan. Okay, table scan or forward scan. Now it is not like previous case where we said only top 10 star, but then we didn't put any order. So there was no guarantee that the rows will come in this order. However, in this particular case, it will be definitely in the order of error, okay, and in the ascending order. So if you see the logical read, now it is 290. That is the size of table which I showed you earlier when we did sp underscore help or sp underscore space use, anything you can use, right? And how much time it has taken? 131 millisecond, 139 milliseconds. So CPU time is 131 and the server elapsed time is 139 milliseconds. So see, just by putting one order by, how much difference it has made. So that is why we say do not put the order by in your query. If you do, then you should support with the index, or you should do it at the application front. Okay, so I hope this is making sense now. Okay, now what we'll do is, so you have seen that it is doing table scan and the 3 operator under root. So one is it has read the complete thing, then sorting second, and then displaying only 10. Okay, so 3 operators under root. Okay, and then to store data it has used work table 1 as you have seen. So basically it is using tempdb. Okay, that's why you see that it has taken a lot more time than how much time it took earlier. Okay, 0 millisecond, and then from 0 to 131 millisecond. So you see how much difference it is there, it is creating once you put the order. Now let us put the same thing but in a different way, in a descending order. Now let us see what happens. Okay, so you see that it's 34 millisecond, it's not like 100, but see that time is very much variable. It can change depending on the load on the server, depending whether it is there in the cache, depending on the strategy of your cache configuration, all that. Okay, so here you see it's again doing table scan. Okay, forward scan. So basically 3 operator under root. So only difference in the previous query and this query is that was in the ascending order and this one is in the descending order. Okay, there is no other difference between these two. So the logical read and all will not change. 30 and 290. In the previous one also you will see 30 and 290. 30 is for work table 1 and 290 is for the actual table because it has to read the complete record. Okay, so far so good, right? Now what we will do is, now we will create one index on this particular column on which we are creating the ordering, right? Ascending or descending. So let us go and create the index now. Index is created. Okay, now let's go back and execute those 2 queries which we did before. Okay, so top 10 star from test underscore messages. So in this there is no order which we have seen. Okay, so here there will be no difference, it will remain exactly same as it was before. However, in the case when you put the order, whether it's ascending or descending, now this will start playing the role. So let us see how it works. So how much it was before? 290 plus 30, right? Now let us see what it is using. Earlier it was using table scan, now it is using the index that we have created. It is forward scan because we have done the index on the, when we don't say it means it's in the ascending order. So you see it is doing forward scan. Okay, positioning at index start. So now it doesn't have to read the complete table, rather it already has a column which is in the form of error column. It can just read from there and based on that it can return you data in the ascending order. Okay, and that's why you have only 2 pages, because one is to read from the error table and then since we are doing star, it has to go back to table to read the other columns. Okay, now let us go back and execute the other one which is order by error descending. Okay, the difference will be let us see how it is. So these things will not change. What will change is it will be backward scan. Earlier it was forward scan. Why? Because when it was ascending orders, it will start reading from the first row and it will go till 10. Now it's in descending orders, it will start from the last one and will read 10 row and will stop there. So forward scan and backward scan. Okay, clear? Okay, very good. So far so good. So now what we'll do is, okay, now let us, so we have seen the operator under root, right? So I showed you 3 operator under root, 2 operator under root here, and then the previous one. So before, when the index was not there, it was having 3 operator under root, right? Now it is 2 operator. Why? Because the index is there. So by creating an index, by introducing an index, you can even reduce the how much operator are getting involved. So that sorting thing which was there by storing it in MDB is eliminated now. Okay, so good, so far so good. Okay, now what we'll do is, we want to show you how the join actually works. So we have taken this data from the master.sys messages, right? So what we'll do now is, now we'll join these 2 table only, okay, and we will create or insert one row and we'll see how it actually, we want to display only the extra row that we have inserted and how the join actually works here, okay. So let us insert one row. Now while inserting, I'll also show you how it actually shows in the execution plan, right? So you see, now we are doing insert into test underscore message table. So the type of query is insert. So before, I am not sure if I talked about this. So it is select, as you can see, okay. The previous one also will remain select, okay. How many operators under root? You see this top limit when we are doing top 10 star, top 10. If we are not doing top, then this limit will not be there, okay. Order by error. Now in the descending order also, I will let me show you. So this is again top limit is 10, but then backward scan, okay. So all good. So now here, yes, so when we do insert here, so the type of query is insert, 2 operator under root, okay, in the table test underscore messages, and then it will also update. The update mode is direct here, inserting directly, it's not deferred, okay. I will talk about that also in some time. So test underscore messages, and then it is 3 logical reads, and total write for this command is 1, and how much time it has taken. So 0 millisecond, and disk time it is 36 millisecond, the complete time, okay. 1 row is affected. All good. So now what we'll do is, now we will we'll execute the thing where we want to show you the row which is extra in this table that just now we have added, okay. So we'll do left join from our table in the user DB to sys messages, and then we'll join on the error code, and then we will say for which the error is null, so which has not found its match, right. So let us execute this. So it will show 1 row. Now let us see how it actually works. So here test underscore messages, you have error as an index, right? And let us see the operator under root, it's 4 operators, okay. Why? Because it is having join, okay, and then multiple conditions are there, and also there is a where clause. So if you count all of them, there will be 4 operators, okay. Now restrict operator, so this is the restrict operator that we have. I mean, it's like too much detailed thing, we should not go into that, but then what is the sensible thing, or what is the thing that will help you, those things I am definitely going to cover, okay. So you see table test underscore messages, so it will use the index error. Why? Because we have an index on the error column, okay. So it has used that. Now let us see what is there. So sys message, so this one it will use table scan, okay, and all that. So test underscore messages scan read count, read is logical read is 320, and for master.sys messages it is 290, okay. So this is table scan, this is forward scan, and yeah, so all that, okay. So when you put the where, that's when I think it's going for, I mean, these 2 it will go for table scan to really find out how much how many rows are there which is actually not matching with that particular condition. So it has to go through the complete data. But then test underscore messages, we have one index, so that will help us here. Okay. So in terms of time, let me show you one more thing. Like it is 19 and 19 now, right? So if you see, so this time will change. It is not really fixed. However, the logical read, this will not change. So you should stick to logical read. Okay, that will not change even if you execute 10 times or 100 times, unless something is changed in the background. I mean, if you have performed reorg rebuild on the table, or if you define an index, or you dropped an index, unless those things are done, the index, the logical read will not change. It could change maybe by few numbers in single digit, or maximum by 2 digit. I have not seen 2 digit actually, I have seen maximum 1 digit. Okay, so that is what it is. So now what we'll do is, so here it's very important that when you are putting this left join, so the right table has to be in the left, and the one that you want to I mean everything from the left, and you are comparing from right. That's why I am putting it test message in the left hand side and sys messages in the right hand side. If you do the other way around, this will not give you the record. So you have to be careful when you are putting the join, right? So when you are doing that, so this will not return data, because if in this case I am doing other way around. Okay, so even logical read and all, you will see it's very less, because it has not really done its job. Okay, so now what we'll do is, if you want to really change the order, then you should put right join, so that this will become in the right. You can see that. Okay, so this reads and all will not change, it will remain same only. You will get the record which we have inserted, which is 20,000 something. Okay, I read for testing 20,000. Okay, clear? All right. Okay, now what we'll do is, now we talked about something that is update, direct update and deferred update, right? So now what we have done, let me do one thing. So 20,000 we have already inserted here, array for testing DB diary. Okay, so what we'll do is, we'll update the description of this. Okay, and then we'll see how it actually works. Okay, so update test underscore messages, set description is equal to, we have added some more fields in that, and then we are doing this. So whenever the columns are having indexed, then it will definitely help in update and delete operation. Insert, it might not help, direct insert. If you are having based on some condition and that's on those column, then it will help. Okay, so here you are seeing that it is using our index here. Okay, now the update mode is deferred underscore var column, because the column that you are having here in the sys messages, that is having some variables. Let me show you if I could. Yeah, you see this all things. So this is based on variable, that is why it is giving var call. Okay, now if you want to see that, so here you see it is very less logical read because of our index. Okay, now this is about deferred update, because we are updating that column, right? Now direct update I already showed you when we did the insert. Now let me show you something else. So update test underscore messages, set error is equal to 25,000, where error is equal to 20,000. Yes, now what will happen? You should think about it. We are updating the error code based on the condition of error code only. Okay, so this will be deferred. Now we have an index on this column, so it will be deferred index. Okay, now let us roll it back, or let us move it back to what it was. I just ran this to show you the deferred update and direct update. Okay, set error is equal to 20,000, where error is equal to 25,000, right? This is what we have updated. We could have done in the begin tran and all. Okay, so that is also there. So we have done this update, direct update and deferred update, and then how it actually looks in the execution plan. So this one you should really see whether it is direct update or deferred update. So I mean, we can't really do anything to fix this thing. This is not even going to impact in the performance, but then this will help you in understanding the execution plan and how the query is actually doing in the background. Suppose it's on the view that you are having this involved, so then you can find it out. Maybe the column which is underlying the underlying definition of view, you should really understand that. Okay, so now what we'll do is now let us create one more table. I want to show you one more thing that is important. Okay, so this will create a table test underscore messages 1 from test underscore message. So basically that we are copying the DDL of this table to different table, okay, without copying any row. Okay, and now what we'll do is we'll create one trigger on this table. Okay, so we are going to use the magical table or the logical table that is there in the Sybase or in any databases, in any RDBMS. Okay, so let us use that. We can define it here only. Okay, so trigger is created. You can find that using sp underscore depends test underscore messages, right? So you will see that you have this trigger defined, which is here ti underscore, because we are doing on the insert, right? We can define column trigger on the index insert, update and delete operation before or after. Okay, this is for insert. So now what we'll do is I will show you something. So here what we have done in the trigger is whenever you insert anything in this particular table, so it will also insert into test underscore messages 1 table. A very simple trigger. Okay, now we are going to insert some row into test underscore messages table. Now let us go back and insert the row. I will also show you the execution plan and the logical read. Okay, so now let us see how it is actually working. So insert into test underscore messages. So query plan for statement 1, the type of query is insert. Okay, 2 operators are there under root. The update mode is direct. Okay, because we are inserting into this, it is not having any deferred stuff. Okay, 2 table test underscore messages. Now what will happen is now it will start executing the trigger, because whenever you have a trigger which is defined on the operation, it has to execute that, then only it will be the operation will be completed, otherwise it will not be completed. So now you see from table, so it is taking the test underscore messages, but then this is something called log scan. This will come, I mean this is very typical thing. Nobody will know about log scan unless, I mean log scan they will think it's from the log, it's not from data and log, it's not kind of that. It is from the table, it's magical table or logical table which you call inserted or deleted. Whenever you have to read from that, this is called log scan. Okay, so it is reading from there and then it is writing into test underscore messages 1. So logical read and all, if you see both the tables are involved, so test underscore messages 1 and test underscore messages. So now if you want to see the record, select star from test underscore messages 1, it will have one record, the one that we have just now inserted. Okay, that's how we use it. So now let us go forward. Okay, before we do that, so let me show you something else. Okay, so we talked about that in the intro. So set statistics, okay, plan cost on. So what this will do is, now this will actually show you the estimated versus actual. Okay, so we have run some queries in the initial thing, right? So let us go ahead and execute them one more time. Okay, so let us see the difference between now and what was there before. So now you see here Okay, so initial part, the no plan and all will remain same. It will not be having any difference. The difference will start when you see this operator tree. Okay, so this is VA2. So VA2 is nothing but the how many operators are involved here. Okay, and then based on that, so you see that, so 1 and 2 operator. So you see that, so read, okay, estimated read, then logical read, estimated logical read, physical read. So it was estimating 3 physical read. However, in this case it has done only 0 physical read. Okay, here now if you see estimated read, it was supposed to be doing 10,988, here 10. So estimated 3, logical 2. Okay, so you see here, so actual is here 2, so it's 2, estimated 3. So when there is huge difference between estimated and actual, then you have some issue in the statistics. It could be out of date. So those things you should see. So here it's really having huge difference. Let me execute one more time and see if that really changes. It's not really changing. So maybe it's out of date. Just now we have created the statistics, but then it's really off. But then this is something which you don't use very often, but if you are a senior DBA and if you really want to understand why there is so much performance gap between what you are anticipating and what is actual, so this will help you in finding out on which operator there is issue, on which in which part of the execution plan there seems to be problem, and then you can go and fix it. Okay, so that is what it is. So let me turn it off now. Okay, so this is done. So we are done with the execution plan and now showing how it actually, how to read that and how to make sense of it. So now while doing all that, while completing session, let us do the cleanup, and then while doing cleanup we can also learn how the delete operation works. Okay, so delete from test underscore messages. So this is the row that we have inserted. Okay, so delete from this. Now let us see how it is there. So it is still using error index. So generally, in the general term, what we say is index only helps in the select operation, doesn't help in the write operation, which is insert, update and delete. However, it actually helps when you have a specific row update or a specific row delete, and mostly we do use specific. We don't say delete from table completely without having any where clause, right? We definitely have some or other condition. So if you support that, then it will definitely going to help you in the operation. Why? Because when you delete anything, so before anything, that whatever anything is that you want to delete, it has to find that out, right? Then only it will delete it. So finding that, it has to read the data. So while reading, it will use your index. So now let us see the plan. So the type of query is delete. Okay, to operator under root. So update mode is direct. Okay, here now you see first it has to read the data, then it will delete it from here. Okay, so that's when your index is very handy. Now we did delete one record, right? Now let us drop the index. Okay, and see how it actually works. So test underscore messages dot error, right? This is what we have created. So we did delete one row. Now let us drop the another the next row that we had inserted for this operation, right? So let us go and delete it. So here the logical read was only 2 and 3. Okay, so one to read and other one to delete. Now let us see so how it actually changes. Okay, so now you see that instead of doing the error table index usage, now it has to go for table scan, and that's how your operation becomes expensive. So before it was 2 and 3, so altogether it was like 5 logical read if you see. Okay, here now it is 290. Okay, so that is what is the difference that you have when you have an index. But then side effect of that is, if you are having index on a specific column, so then it has to delete, it has to update the record in the copied column, which is index column. So as I mentioned before, so when you create an index, so basically you are creating a copy of those columns in a different location. So when you delete anything, so it has to update, it has to delete from the table as well as from the index. So that's why you have little bit of extra cost here. Whereas in this case, now there is no any index, it doesn't have to update anything, right? That is why you have less cost, but then now it has to do the complete table scan instead of using that index. So it becomes more expensive. Okay. Now I mean I have showed you delete. So now you can just do drop and truncate. So you can do truncate table test underscore messages 1. It was having one row. Okay. So truncate table, the type of query, and then how much write is involved. So if you don't have update, insert, delete, there will not be write operation. It will be there only when there is write operation involved. So when you do select star from that, so there is no any. So this was also delete. That's why you had one write operation. So in case of normal things, okay, it will be 0. All the read will be actually it will be 0. So this one I showed, the previous one 0. Okay. So now we can just drop table test underscore messages 1. Okay. So you will see that it's again having write operation. There is no read thing involved. Okay. So you can do truncate table again, or you can just do drop table test underscore messages, and you see how it works. So the type of query is drop table. The writes, it's 6 things. It is right. It is having 6 write commands. Okay. So total write for this command is 6, and then how much time it has taken. So you will see CPU time is 2 millisecond and the complete time it has taken is 34 millisecond. Okay. So I think we are done. So in this topic we covered about the execution plan. We covered about the logical read. Physical read, I don't think there was any, but this is where you can see physical read. So wherever you have physical read involved, that means you are really in big trouble. Okay. And you should ensure that it is really able to fit into the cache, so that you will have logical read. One more thing which I think I did not talk about that. Yeah. So this LRU buffer replacement strategy. So this is actually you should see it is LRU or MRU. So you can find that using sp underscore config cache config and see what is the configuration you have. So you see what we have, it is LRU, right? And so that is why the sorting and all is happening in the index leaf page using which strategy? LRU. If it is MRU, it will show you MRU. Okay. So all that you will see, it will use LRU. Okay, table scan LRU. Okay. So wherever logical reads are involved, you will have LRU and MRU based on the cache configuration. Okay, so we covered logical read, we covered physical read, we covered LRU, MRU, how it actually is dictated. Then we also covered about the statistics plan cost, like how it is there, actual estimated and actual reads, right? And we also talked about how the index helps in write operation and how index actually helps when you are having any order by clause or anything in the where clause. Okay, so I hope this will help. Do let me know in case of any question, and feel free to ask me. Okay, so thank you very much. I really appreciate your time and watching my channel and subscribing to that. Thank you very much. Appreciate it. Bye.